There we go. All right. So it's the same idea. I mean, if we talk about it, an actor standing alone can't be the same thing. A microservice by itself isn't really a microservice because it works with other systems to do things. Just like a single soldier doesn't have the same effect that an army does. So microservices come in systems, and I think this is really important to drive home the idea that we're breaking our monolith apart into small components that work together to a bigger vision. A typical application is going to be made up of more than one microservice. This is the idea of a system that I'm talking about. There's a lot of frameworks that make individual microservices easy. There's lots of them. I have no criticism of most of the microservice frameworks out there. The criticism that I do have is that many of them do not enable you to build systems. And that's really important because how do you coordinate between these things? Do you have to build your own discovery service? Do you have to build your own RPC mechanism? Do you have to find ways of linking all of these things together? And that's important. So the idea behind Lagom is to build great microservices, but allow us to compose them, to put all of our microservices together and build a system. And again, I see this as really important because one microservice is not a microservice. It's just a little monolith with not a lot of code in it. So building microservices, most importantly, shouldn't hurt. And this poor gentleman sometimes feels like his head is being crushed by a mountain. So if we talk about this not hurting, it was important from the beginning, from the vision of where this came from, that Lagom provide a great development environment. And that's important, I hope, to all of us. If we're building tools for other people to use, we don't want them to be cursing us and putting pins in voodoo dolls at the end of the day every day. We want things to be good, but we're driven by this. It's really important to make this experience good. And it shouldn't take a mountain of scripts to set up a development environment. One of the things I find myself doing a lot lately when I set up development environments is Docker compose, because hey, I can spin up Kafka and Cassandra and everything else, and it's easy, but it still requires a lot of scripts and other things. And that's somewhere where we've aimed to make that easier. You get a new developer starting up, it's easy for them to start with their development environment. So as I said, a new developer should be able to jump right in. And for a lot of instances I've seen, that's one of the big friction points. You get someone new on your team and you spend so much time getting them up to speed. So if you have a framework system that makes that easy, that's great. And that's really what Lagom is. We've even got hot reloading. We've had that in play for a while. You see that in other frameworks. But that's one of the things that's great, for example, with, say, PHP or Python. You make a code change, you hit refresh. So the same thing in development mode. We can quickly make changes and see them without going through the whole recompilation process, the joys of incremental compilation. There is one more important opinion than everything else. And I know we all love buzzwords, so fair warning, I am going to use the R word. Just like everything else, sometimes these things get overused. But we are going to talk about reactive. Because if we think about it in the right way, if we use reactive correctly, it really matters. The principles are fundamental to how we build systems today. And so reactive systems have really 4 elements that make them what they are. They have to be responsive. They have to respond in a timely manner. Otherwise, we're looking for a new job because our company's not particularly thrilled that it takes 10 minutes to load a page. But this is important, and there's lots of things that come together. Being responsive by itself doesn't really do it. If you look at the diagram on the side, you'll see that all of these things are interlinked because they all build a framework together. And they are resilient, which means that when we have failure, we stay responsive. Things like bulkheading, making sure that an exception doesn't take out our whole system. And that's really foundational, not tossing exceptions all the way up the stack. And elastic, which means that we have to remain responsive under varying workloads. And most of the time we think of that as scaling up. Hey, can I quickly add more instances of this service? But that also can be scaling down when someone comes to you and asks why your AWS bill is 10 grand a month. Hey, can we get rid of some things and still have the system work? And finally, message-driven, or event-driven if you want to think of that, because we have to react, and that's a big part of where we talk about being reactive. It's having things pushed into us instead of pulling. You know, the going on a long trip as a kid and constantly asking your parents, are we there yet, has a cost to it, just like polling for things does. And this is where message-driven systems can really help. If they have a message-driven foundation, they react to events, which allows us to drive things in a performant manner. So if we look at Lagom as a reactive framework, we've built it from the ground up to do these things, to follow these principles, to work with the things that all of us have seen over many years. It is asynchronous by default. That's a really important underlying factor. And this is from the I/O layer up. Under the covers, you're looking at a Netty implementation for the networking. We use Akka streams for asynchronous streaming. Akka streams is a solid reference implementation of the reactive stream spec. We have Java 8 completion stage for your async computation. And we support inter-service communication via streaming, because this is a big part of microservices. If we say that one microservice isn't a microservice, many microservices make a system, and that's really a microservice. They have to be able to talk to one another. And another great thing is that WebSocket support is built in. And this integrates with our streaming and async messaging. And there are some interesting places where it just sort of says, okay, we're going to use WebSockets here because it's the right answer to what we're doing. So it is built from the ground up to help us build truly reactive systems. The other thing, because I talked about this idea of resiliency and scalability and everything else, is that it's distributed by default. There is clustering technology built in that makes it pretty easy to do these things. So we've built this, as I said, with strong, proven technologies. I sort of sound like I'm marketing a little more than I'd like to here, but it's important to think of that. I mean, we want foundations to what we're doing that make sense, that have been proven for what we do. Now, Lagom is primarily written in Scala because it's based on Play and Akka, but in our ecosystem, both for Play and Akka and Lagom, Java is a first-class citizen. Since the most recent major releases, actually I think Play now has had 2 major releases. We've had full support for Java 8 Lambdas. There's some interesting stuff as Scala 2.12 comes out of even cleaner integration between Scala's version of Lambdas and Java's. So that's really important. It's a first-class citizen. And in fact, with Lagom, we've released it as a Java product now. That is its focus. There will be a Scala API down the road, but this is built with the Java developer in mind because there's a niche to fill. How do we take these concepts and really get you on the right path? So we have a Java 8 API, as I said. It leverages Lambdas. It makes it really easy. There's a relatively fluid API for building what we need. There is Cassandra, which acts as a default database for our persistence module. There are certainly APIs for you to plug in your own thing, but Cassandra is a pretty popular database to fit within this reactive model. And there's an embedded development server for Cassandra, so when you run your dev mode, you don't have to install Cassandra on your machine. And we use Jackson, which is a relatively popular JSON library, as our default implementation. So when you do JSON serialization and deserialization, by default it's going through Jackson. So the best tools do build the best framework. The Play framework. This has been around for a long time. Play 1 was Java, sort of near the end of Play 1's life cycle. They added Scala support, and ultimately Play 2 became Scala. And it's a strong web framework for doing these things. So this is a Netty-based system for your I/O, and it powers the HTTP side of Lagom. Because we're building RESTful services with our microservice, we need an HTTP interface. There's also Juice-based dependency injection, and this is the default in Play. We're using Juice for dependency injection to give us easy configuration and composition. And Akka. Now, I've been involved in Akka for a long time. I did an early production deployment of it. I am a strong believer in Akka. I am not easily swayed from that opinion. And it's the right tool to sit underneath Play. This is battle tested. This actor framework has been used in some pretty amazing places to do some pretty amazing things, and it's the foundation of what we're building. So first of all, this is where we get our clustering, making it easy to spin up multiple microservices and scale. We have persistence, which gives us event sourcing, which we'll talk about, and streams, which give us pretty strong asynchronous interaction. As far as clustering goes, we do have a subscription platform which has some extra implementations of things like split brain, which can always be a problem with clusters of what happens if there's a net split. But clustering in general is a free product. It's available with Akka. It comes out of the box with Lagom. And we have Kafka support, I think, coming with 1.2. And that acts as a message broker. So that's going to be something that pushes more and more so that we have another way of communicating between services. And like Cassandra, it is built in to that development environment. So if we want to start a new Lagom project, and actually I think, unfortunately, I didn't fill in this slide. I cut and pasted something that didn't get in there. What I will say, very briefly, is that the default, and this is where we started with Lagom, was with SBT, which is the Scala build tool. Not necessarily ideal for a bunch of Java developers, but because it was written, we have added Maven support. You can jump right in. We have an archetype for Maven, so you can do a Maven archetype and directly generate a project. But let's talk about Lagom's service API, because this is the first piece. How do we communicate with a service that's built on Lagom? So we describe our services as interfaces. We call them service descriptors. And these are the invocation, the implementation, the metadata for how do we call something and how do we serve it. And they're transport agnostic. They really don't care. Right now, we sort of support REST and WebSockets, but eventually, who knows what else could go on there. You know, once we plug things in, these services are meant to be generic and have an easy ability to plug into whatever layer you put in there. Hey, maybe Gopher will make a comeback. So this is a rough sketch of a sample of an interface to define the root of a service call. And if you sat in the keynote, you may have noticed I mentioned, yes, we are making lots of use of things like defaults and interfaces, because it allows us to build a good, strong base that we can reuse for our services. So this is a service call that takes a string and returns a string. The name of this descriptor, hello service, is what's used for discovery, so that once you have your microservice system, you can say, hey, I need the hello service, and find it and communicate with it. And here we have defined a single service called say hello, which is the service call that we're going to fill in. And this would respond to an HTTP request. So if we're using this with REST, Lagom would directly map this to a post request mounted on /say hello. The way it's implemented here, it's just going to be text/plain for both the request and the response. Because we haven't hooked in any JSON objects or anything else, a string is a string, it's plain text. Now, it is also possible to accept path parameters. I mean, if we build RESTful services, this is the way you're supposed to do things. If you want to retrieve information about a user, you do a get call to /users/Brendan or /users/123. And so we can easily build these in. What's great is Lagom, if you say in your service call that it needs an int, Lagom has built-in deserializers. It will try to extract that correctly for you. And although I don't have it up here, you can have multiple path parameters. Because when your REST services get to be really complex and crazy, you can sometimes get to the point where you need multiple path arguments. And there is also query string. So if you notice here, it's just question page no and page size, but the service call interface here is taking a long of order ID and an int of page number and page size. So you can sort of directly define your interface that says these are acceptable requests, and please fill in whatever parameters come through here. Now the service call defines what we are actually doing when we receive a request. And this is invoked when I consume a service. So there's two types here. You'll see request and response, which are passed in to the type template. The request, hopefully, if we've worked with HTTP, shouldn't be a surprise, is the type of the request we've gotten, for example, a string. And the response is what we send back. Again, by example, might be a string here. By default, JSON is used as the serialization format for request and response messages. And there are two kinds of request response messages that I'll talk about briefly. There are strict and streamed. And we want to look at the differentiation between them because strict isn't perfect for everything, streamed isn't perfect for everything. But combined together, we can build a good system that works. So strict messages aren't particularly difficult. They are really just represented by simple Java objects, your POJO or whatever else you want to call it. With these messages, buffer into memory. We parse them from the source, such as JSON. They're concrete. They're immediately materialized. And if both our request and our response are strict, we're considered to have built a synchronous call, sort of our classic HTTP system. Where it gets interesting is with streamed messages. And if you look at the change here, I have got a service call whose response is a source of string. And it's taking a tick as an argument. So here the path call takes an interval. And the idea here is I'm returning a source, which represents a stream. And this changes the picture because now I can stream a response and keep it open and keep pushing information, which is relatively relevant to the way that we build web applications today. So these messages, they represent an Akka stream. They are represented by source. The big thing is, as I said, they're truly asynchronous handling of messages. In this example, the request is strict, but the response is streamed. And so we will stream out a string at the specified interval. I can keep pushing results into that stream. The request doesn't have to end as soon as I return. And this will automatically select WebSocket as the transport protocol. So Lagom will say, hey, well, if we're going to do streams, WebSocket is the right way to do it. So if we want to implement these services, regardless of whether I use strict messages or streamed messages, we need to actually build an implementation class, which extends that service interface that we built before. And as I said, the fact that we've got defaults in interfaces for Java is a wonderful thing. It makes these kinds of things so much easier to compose. So I have got a public service call with stricts, but you may notice, so as we provide an implementation of the descriptor interface, this is implemented using a Lambda. So I am returning a completed future in this case. So I really haven't, it's not a true Lambda, but it's a completed future. But the biggest thing is that what we return here isn't immediately executed. So we can compose it. Maybe we have an authentication layer. Some kinds of things, often in HTTP and other applications, we've got to stick things together and compose them. So by having deferred execution, by having either a delayed function or call by name or something else, we can build these things easily. So there's not too much, hopefully, from the point of view of where you've seen, to getting your interfaces together. Now, there's lots of other things. There's multiple paths. There's looking more at the streams. But we could spend hours sitting here and looking at that. There's another really important piece, and I mentioned there are the parts that when I started to learn them, I kind of smelled the smoke coming out of my ears. Because they are a shift in the way that we think, and there's probably more than a few of you, maybe all of you in the room who've seen this before, but this is behind our persistence API. And if you've worked with Akka, you definitely may have worked with Akka persistence, which is where I first saw these things. So the first part, and this is a really important thing with every microservice. In addition to the fact that one microservice by itself is really just a mini monolith, they have to own and they have to isolate their data. In order for microservices to be flexible, for us to get the benefit that we need, which is that we can have a team working on each piece, I can do a release of one component of the system, is they have to isolate their data. And that means that only this service has direct access to its database. All of the things that the service domain represents are in that database, and no one else can directly touch that database if we've built things correctly. So that if our other services, and again, we should have other services, we're building a system, need access to that information, they use the services protocol. Or there's other ways in this model. You can use something like Kafka or a pub sub bus so that you broadcast information, but the systems receiving that broadcast wouldn't be your system of record. Your system of record will be where that database is. So if you want that info, you come and you ask me nicely through my HTTP interface. Since we've already admitted to being opinionated, in other words, I'm going to tell you how you have to build your service, and you're going to like it or not, but you're going to do it my way. The best way to do this, from what we found, is event sourcing and CQRS. And unfortunately, we cannot click on my slides, but I have linked them here when I post the PDF. Both of these link for event sourcing and CQRS to Martin Fowler's website. He's got very, very good concrete descriptions of these concepts. We also have good ones in the Lagom docs, but that's always the reference. The Martin Fowler stuff is where I go back to kind of remember, am I doing this right or not? Or am I telling people completely the wrong thing? So the first piece is event sourcing. And the idea with event sourcing, first of all, immutability becomes important. And if any of you have worked with Scala or know Scala developers, you know that we're a little wrong in the head and obsessed with immutability because it makes concurrency easy. But with event sourcing, all of our state changes are events. They're treated as immutable records. Each thing that happens is an event. Brendan took $1 out of the ATM. Brendan took $10 out of the ATM. Brendan set $10 on fire. All of these things are events that are recorded that in this case affect my bank balance. So rather than having something, I mean, we've probably all worked with ORMs, Hibernate or whatever else, where we've tried to make objects feel like they sit in our database. We change this over from an object relational approach to events that are captured directly to a log. In this case, it's an event log, sometimes known as a journal. Each item that happens, orders that are placed, money taken out of ATM, each event goes into this log. And this event stream is interesting because it can be analyzed. And one of the things I found early on that was really cool about this is the realization that it was really easy to tell a customer, by the way, you've got an audit log. So if you've got somebody who's doing something where they need to know everything that happened to, say, your balance of your bank account, you can look at the audit log and see every event that occurred. So we can derive useful information. But we build new read views that are separate from our writes. We don't complicate our writes. And this is part of where CQRS comes in. We separate these things out. The great thing as well about event sourcing is because it's focused on append-only writes, event, not updates. That we get excellent write performance if we're using the right database and the right structure because they are append-only. And it actually is surprisingly easy to test and debug these things. Simulation is pretty trivial when you can just feed a bunch of events in and see what happens. It's almost a pure, it's not truly a pure function, but that idea, if I feed things in, I should see the right result. And I can do that. I can reset my journal and simulate what I need to. And debugging is easy because I have a list of all the events that are there. Now, the other piece of this that comes together with event sourcing to make this really powerful is CQRS. Not really but CQRS stands for Command Query Responsibility Segregation. We're talking about saying commands, things that we have to do, are really separate from queries. Although when we talk about queries in this case, we're really talking about things like, give me all the users born in 1984, as opposed to give me the user for Brendan. They treat our write operations distinctly from most of our read operations. And because of this, it pairs really nicely, as I said, with event sourcing. Writes are always targeted to a specifically identified entity. You do a write to user Brendan or to user 123. But we can do reads. So we talk about the queries being separate, but it's fairly normal that your entity representation for a user can respond to queries directly about that user. When we talk about the reads or the queries, we're talking at a bigger view. Like I said, all the users born in 1984. And that's exactly what I've just said. My bullet point, I'm running ahead on it. But we build these as separate sections of code. We can separate these out and make it easier to control and work with. So how this all comes together is my clicker. See, tying these together, we get a lot of value. As I said, from pairing these things together, and the appending of logs of events makes it easy to do the queries and other things, We can do time traveling, or for different values of time travel, however you want to look at it, by which I mean playing back events. Hey, you've got a serious bug in production, the data isn't right. Think about how great it is that you can go back and play back every step that happened. Or, as I said, you can do your auditing, but also rebuilding state. Whether it's for, one of the things that I've always found difficult building applications is how do I take a simulation of production load? Well, if I've got a journal of every event that happened, I can replay that. I can give people the ability to audit what has happened in my system. So we can say goodbye to what I've always considered to be the tyranny of ORMs. I've never been thrilled with ORMs. And we don't have to deal with database migration scripts because it's just a journal. The events are going in there. We're logging the objects, but we're not trying to map them to big objects. So we get performance, we get scalability, we get good testing, good debugging, and they all benefit from this event logging model. To start with, if we want to write with event sourcing, and there are a bunch of layers to this. I am not going to, unfortunately, cover every little piece of this, but we'll talk about the core pieces and look at some of the core APIs. Most importantly, I want you to hopefully to walk away understanding event sourcing, CQRS, and why we're using these to drive our microservices. To start with, we have to create commands and events, and these are a pair. Commands can potentially generate an event using a subclass of persistent entity. So we define handlers. What happens when a command occurs? What happens when an event occurs? These are represented by entities, and an entity really is an individual thing. So I have a persistent entity implementation called user, but an individual entity is an instance of user with a given ID or a given name. Does that make sense? So we're sort of looking at something like sharding. They can be accessed from anywhere in a cluster, and the way we do things if you're clustering is we shard them out, we distribute them. It's something that Akka has built in and Lagom interfaces with. If you think in terms of domain-driven design, which is something that I see a lot of now, a lot of people are saying, hey, how does this correlate? This corresponds to an aggregate root. And the Lagom docs, in many cases, will talk about the DDD links, which is helpful if you think in terms of DDD, of where do I have to break down my ubiquitous language or anything else. And this is a terrible slide, which has lots of things on it. I apologize. It's supposed to be like bullet pointed, and it appears it's not. So to start with, a persistent entity has a stable identifier. That's the thing like the user ID or the name that I talked about. And this is how we access it. We access its service implementation and other places, how we find things. So interacting is accomplished by commands. All of the interaction with a persistent entity is sending it an instance of a command, a thing to do. Do a write, give me a query, whatever else. Commands, most importantly, are processed sequentially and one at a time, so that a given entity can process one event at a time, and it processes them in order. This is important when we're doing things like building an event log to make sure that the events occur in the order that they were sent. Concurrency is hard. It's nice to have a system that keeps us from running into the, hey, why did 15 things happen in the wrong order? Now, depending on our code, and this is important, a lot of people miss this when they look at, say, Akka persistence or Lagom's persistence, is that a command does not have to change your state, but it may change your state. And if you change your state, you can persist that as an event. That's the event that goes in the log. You choose in response to a command to say, hey, some event occurred. Now, I should note, the current state is not stored for every change. There is a snapshotting system where you can say, hey, if I start back up, I don't really want to replay 3 years worth of events. But when you have a normal event, it is $1 was added to my account, not my account balance is $2. I hope my account balance isn't $2. The event log is append only. There is no mutation. And the biggest thing, as I said, because we're doing append only, if you've done a lot of work with databases, updates are a lot harder than just straight writes. We get great write throughput, we get great efficiency. So if we look at our individual entity instances, as I said, these are automatically distributed. They're sharded across cluster nodes. What's great as well is the sharding system in Akka is phenomenal. But it can take some work to get it up and running. Lagom just does this for us automatically when we build our systems if we build out a cluster. So they are distributed across cluster nodes. We've got balance, which means that all of our user entities aren't existing on one machine. They are kept alive. But what I mean is long, and there's a configurable timeout, but as long as you are requesting this entity regularly, it's going to be kept alive. Its state is going to be held in memory for as long as it's used. If that timeout occurs, a passivation occurs, which is great because, hey, you know, this guy hasn't logged in 3 weeks. Why are we using a gig of memory to store all of his information? So they will automatically be passivated. But remember, we've got an event log so that if we passivate a user and then he logs in later, we can replay his event log, rebuild his state or her state, and have this instance up and ready to go. So it gives us this ability to not have to hold everything in memory, but also not have to constantly read from the database. I really need to replace this clicker. The persistence API, I should note, is not enabled by default. You just have to add a dependency. And if it matters for SBT users, it's if you're using the Lagom plugin for SBT, it's just a built-in. You say the Lagom Java DSL for persistence, and there's a Maven statement as well that just says bring in the Java DSL for persistence. This gives us our API. Now the default, and of course we're opinionated. As I said, remember that whole opinionated thing. This is us saying not so subtly, hey, you probably should use this, is that our default data store is Cassandra. That's where it really seems to be the sweet spot. That's where I've certainly over the last year or so seen people who are doing raw Akka persistence going with their journaling, so it works well. Cassandra is highly scalable. It's well distributed. It's a really good fit for that Lagom model. It fits into that reactive concept. And so if we start a light stub, our persistence entity might look a little bit like this, where I've got my public class post one. We're going to talk about these type arguments in a minute. And we do have to implement our initial behavior. The other thing, as I mentioned, we're using Java 8 lambdas. Optional is important as well. You know, conceptually, instead of saying something is null, we have a type that says it should be a blog state. It might not have a value, but if you try to read the value, you're not going to get a null pointer exception. You're going to be told, hey, you need to unpack this. And that potentially, you know, gives us our behavior. This is what we do when commands come in. So there are 3 type parameters to this class. You'll see them here: blog command, blog event, and blog state. So the first one is a command. This is our base interface for the commands that come in. These are the things that we execute in our event source. In this case, it's a blog command, something to do with the blog: update, write comment, delete post, whatever else. The second argument is an event, something that is triggered by a command. When the command comes in, a potential event is created, which is a blog event. This is an object that can hold information about what that event is. And finally, state. Within each entity, there is an object that holds the state of that entity, the current balance based upon the journal. And this represents our state for the entity, and we've implemented this as blog state. You know, blog state might just hold an integer, or it might hold something more complex. Maybe it has a detailed graph of all of your friends on your blog or whatever else. Initial behavior is abstract. We have to fill this in. We have to implement it. What it does is it returns an instance of behavior. This is a chain of operations that defines how we handle commands. So it's really, in Scala terms, it's a pattern match. I mean, it's really just an if-else. If it's this command, run this. So we provide a nice builder interface for behavior, which is new behavior builder, which simplifies this. So that when we call initial behavior, we can build up a chain. We don't have to write a whole class with everything in there. We can add things. We can separate out our concern or whatever else. So if we use set command handler, B in this case is an instance of that behavior builder. What I'm doing here is Oh, sorry, my brain is short-circuiting. Oh, I am looking directly at what I'm looking for. So I'm setting the command handler here. And this says that if I get an add post, so this is specifically the command add post, this is what to do. And in this case, we provide it with a lambda. That lambda is going to get 2 arguments. It's going to get the actual command that came in and an instance of a context. The context holds information about what's currently happening in our entity, because this is a callback function. And we do some work with this, and you'll see there's a mention of persist. And let's talk about what those different persist commands do. So first, these command handlers, as I said, these are invoked for every incoming message. So as long as there's a match for that type of command that comes in, it will execute your handler. And these must return events to be persisted, if any. There is an event that you can return that says no event has occurred, but you know what I mean. You have to return something that represents an event. So we have to return an instance of a directive called persist. These define, as I said, what events, if any, have occurred. The first one is then persist, which is a method which persists a single event. So one event has occurred here in response to this command. There's also then persist all. This is the idea of several events have to occur, but they also occur atomically. So most importantly, it's essentially transactional. They all have to succeed in persisting, or an error occurs and none of them go through. And finally, done says, I don't want to do anything. There are plenty of operations that don't cause an event. A very common one would be a read. What is the bank balance of this user is a command, but it doesn't create an event unless we're auditing what's going on there. So it is possible as well for us to perform side effects using another method, which is after persist. So we could say, once you're done persisting, perform some other side effect. I've seen a very common one is after persisting is done, drop a message onto an event bus like Kafka so that other systems can be aware the bank balance is now $3. So it is optional, but there is support for validating commands as well. And we do this before I persist any state change. So there you can use either context.invalid command or context command failed. And this will just flat out reject a command. This allows us to check, for example, are things null that shouldn't have been null or something else. You do not have to change state. This is another place where I find people get confused when they work with event sourcing and implementations like this, that a command does not have any requirement to affect a state change. It's entirely optional. You choose, how do I respond to a command? Does some event occur? A very common example, as I said, is a query. A query command isn't going to generate an event. So if we want to do this, we can register a set read-only command handler, which makes things easy, and there's a reply method on the context, which allows us to send a message back. For example, in this case, the contents of our state object, because our query was, hey, what's the balance? Now, it's really important here that commands have to be immutable because of the wonderful perils of concurrency. If we leak a mutable object outside of our entity and someone mutates it, they potentially can affect the state of our entity, and it's no longer pristine or trustable. So making these objects immutable is important. And as part of that, it changes how we handle events. The state is immutable, as we'll see. So once an event has been persisted, we update our state. So we're going to register a handler with setEventHandler, which is exactly this, which says when it's a post added and the event occurs, update the state with content. But what's important here is this handler returns a new state. In order to prevent that accident that can occur of someone returning a mutable state to someone, you need to build your state object to be immutable. So there's a mutable variable hidden within this persistent entity, which is updated with the new immutable state representation. And so we will return an updated representation. So typically you'll have some kind of method on there that allows you to update individual pieces. this will return, and as I said, it's this pesky concurrency thing again. So we all know concurrency is fun to deal with. So the other thing is the current state is always accessible from within event handlers by calling persistent entity state methods. So it's not hidden away from you. You always can access this persistent entity state. And we generally should define an event handler for each event that our entity persists. We want to handle these things that are occurring. And these handlers are used for both persistence and replays. A replay is what occurs when maybe our system crashes or we've passivated an actor and we bring them back up. We replay the event log to recreate the state. And so these items are used to recreate what's going on there. A couple more things. And as I said, there's only so much time to cover everything. And these are things that once you've got the core, we can look at a little further. Every command handler has to define what type of message it sends as a reply. A command handler is supposed to give some kind of acknowledgement. And this implements a class called persistententity.replyType. There is the ability to change the behavior of an entity. This is actually something that comes from the actor model. You can say, change the entire code. So you'll notice that method was called initial behavior. That says essentially when this class first starts, this is the behavior, but there are functions to change the behavior. And we often use this to implement things like finite state machines. And finally, there is support for snapshotting. As I said, I don't necessarily want to replay 3 years of bank transactions. So maybe at the end of each day, I create a snapshot that updates the journal and just says the state is currently this. And when I start back up, I will read the last snapshot and every event that has occurred since that snapshot to simplify the replay. And the API for that is relatively simple once you get a handle on things. It's a method call to create that. Reading with event sourcing, it is possible. It's an interesting change because we don't read directly from the journal. Instead, we register some stuff that says, I also want you, when events occur, to create this other database. The classic example is you don't necessarily want your business analysts querying the production database with some gigantic SQL query that's going to impact the performance of your system. So we create a separate area for these reads. So in a typical Lagom setup, it's often tightly integrated with Cassandra. There's that opinionated thing again. So we have to subclass Cassandra read side processor, and this will consume all of the events that are produced by that persistent entity and update tables in Cassandra that are optimized for our queries. So this is separate from the event log. This is just essentially subscribing to hear about these events and creating some representation that can be used for our queries. And we can then use, say, CQL, the Cassandra query language, something like select ID and title from post summary. And now you've got this whole other area that allows you to do the analysis where you've built a structure that's perfect for reads while not taking the performance hit of what you need with writing. So to run Lagom in production, very briefly, there is a plugin for SBT called SBT Native Packager. What's great about it is it can generate zip files, MSIs, RPMs, DEBs, and not just Docker files, it can generate Docker images. I use this a lot for local testing, as I said. It's fantastic to be able to just have your build tool spit out a ready-to-go Docker image. We also have Lightbend Conductor, which is a container orchestration tool. This can simplify coordination of cluster setups, especially with Lagom. In addition to Conductor, we do have our Lightbend Reactive platform. This is a subscription service, but for development, it's completely free. So you can sort of get a feel for it, but it is not required to use Lagom. It can potentially make this cluster management easier. Split brain resolution. If any of you have dealt with clustering, it's a scary area to get in if you have a net split or something else and resolve which parts of the cluster stay up, which parts of the cluster are the system of record, and there is a split brain plugin that helps to resolve that, and a monitoring suite, which can give you a lot of introspection and information about what's happening within your Lagom services, or your Play services, or your Akka services. So what is in the future? And actually, I was looking, the slide I was looking at yesterday from a colleague, so I realized, hey, a bunch of the things on his what's in the future from a month ago are no longer in the future. We have recently, as I said, added integration for Maven. I've heard rumblings about Gradle, but I don't know what the story is on that. Obviously, Gradle is a popular tool as well. And Maven obviously is popular among Java devs. You don't necessarily want to pick up SBT if you haven't used that before. And Kafka integration has come in as well, or is coming in the upcoming release, where like Cassandra, it will sort of be built in. Kafka is becoming bigger and bigger and bigger in what people are using for this kind of work. In the near future, we will add a Scala API. So those of you who are Scala developers, we're headed in that direction. It's going to be there. Enhanced support is coming as well for writing better integration tests. And work is being done right now on support for other cluster orchestration tools. Because people have different platforms and they want to manage things. Lagom is open source. Pretty much everything we do other than that reactive platform that I mentioned is open source. We love contributions. One of the things that makes these products better is when the people who use them come back and say, hey, I've got an idea. So by example, Christopher Hunt, who's the tech lead on our Conductor suite, is working on a Kubernetes integration and would love open source contributions. And that leaves me with, I'm not actually going to drop what's probably a very expensive microphone, but I will open, we have a few minutes to any questions. I know I've filled your brain with a lot of things. Yes? Okay.
What about how it's easy to integrate existing microservice to Lagom ecosystem? For example, what if I would like to move from Spring Cloud to Lagom? And what the benefits on the Spring Cloud?
So migrating from something else like Spring Cloud to Lagom, I don't know they have a good picture for that. Because as I said, we are sort of an opinionated framework. We have a strong model that's there, and I think what you're really looking at is a new implementation for this, rather than bridging into something else would be the approach that I would take there.
And the second question, what about Reactive Stream API? Is it planning to support this feature in Lagom ecosystem too?
So, which, the Java streams?
Reactive Streams API.
Well, that is. So Akka streams, which is what we use within Lagom, is the reference or one of the reference implementations for reactive streams. So that is, Akka streams is completely reactive streams. Our team helped put together the reactive streams spec, and Akka streams was the sort of test bed for where they experimented with those ideas to get on the right path. And certainly Netflix gets a lot of credit as well with RX Java pushing a lot of those ideas, but Akka Streams is meant to fill completely in with that reactive streams. There's a question over here in the blue.
It's not a secret that CQRS doesn't fit well with majority of projects. But suppose we have suppose we're making a project from scratch, what should lead us to use CQRS and especially Lagom?
So, as I said before, one of the things with Lagom is that note that, remember I said the persistence API is optional. Persistence API, which uses event sourcing and CQRS. And you're right, it's not going to fit with everything. But if you look at your breakdown of things, especially things like keeping track of constant event streams and other things, those fit well with CQRS. But you're right, not everything is going to fit that. But if I'm doing something like keeping track of changes to discrete entities, updates to bank balances, scores, whatever else it is, that fits really well for me. But you can just go straight out with the service interface on Lagom as well, which again is meant to give you, things, easy descriptions of what your REST services are, easy interfaces where if you use streams, you generate WebSockets, and all of these other things.
Thank you. So, and one more question. Suppose we choose CQRS and event sourcing. So, but there are a lot of libraries like Exxon So what are the benefits of using Lagom over the rest of the libraries?
So I don't know that I'm familiar enough with any of the libraries to make a good commentary on that. Certainly from one of this is we have built this on top of, for example, having strong clustering capability. And that's one of the places where I look at immediately. As I said, microservices have to come in a system. One microservice by itself is just a mini monolith. And having, that's the biggest thing, the frameworks I have looked at, often I don't see an easy way to scale out by having integrated clustering. And that is a place where I certainly look when I look at software tools right now, is to make sure that I have a good clustering solution that's not going to make me scream.
Hello. If I will come back to my country and we will start work with Lagom, of course we will have some questions with starting. Where can I ask it? Where is your community based?
So, I'm sorry, where is the documentation or?
No, community, something like Stack Overflow, or where I can ask my questions.
So there are mailing lists. We certainly, there are mailing lists for Lagom is the big one. I forget, I think we have a Gitter channel. I wouldn't hold me to that, but we usually have more than a few communication methods. And certainly it's listed there. It's relatively easy to get a hold of the developers, but the first place I would start would be the mailing list, which is linked from the Lagom website. Mm-hmm. Certainly, you can reach out to me as well. My email address is out here. I'm always happy to help people get pointed in the right direction.
Okay, thanks.
Well, Lagoon services, are they actually actors, or what stands behind this?
So if you're using persistence, they are actors. It's built on top of Okka's persistent actors.
And does it make sense to integrate with existing actors that you had, or you have to rewrite it?
I don't think, there's nothing that restricts you from doing that. I think, and I'm getting the X-arm, so we'll finish up this question. I don't think there's anything that restricts you from doing that. It's not necessarily, and I think we're aiming right now for sort of building these closely composed, but you do have actors there. A lot of the stuff like the actor system and other things are composed away from you to keep you focused on that entity API. But it is running Akka, it's running actors under the covers, it's using the persistence system, the sharding, and the clustering.
All right, thanks.
I think I got the timeout, so thank you very much. I'm happy to answer a couple questions as we finish up. And there are some books and stickers up here as well. As I said, Marcus's book has sort of a good, continue to dive through Lagom. And Jonas's in particular really covers, whether you use Lagom or not, really strong concepts for building good microservices.